Hello, welcome to the configuration of an offline object video. In this video, you will learn the definition of an offline object, the architecture of offline objects, the configuration of the offline object services. An offline object is the solution to the synchronization problem that apps face when they must work offline. Offline object is a new synchronization capability built on the top of object services. Using offline objects feature, users can download data of the objects from the Koni Fabric Object Service to a mobile device. When the device does not have a network, the downloaded data is used. Once the device gets the network, data is synced with the Koni Fabric Object Services backend. Offline objects maintain a delta history of data in the local device. So, only the data that is changed is sent, and not the entire app data. If you made some changes which you are not happy with, you can easily roll back to the previous state. Let us see the common issues faced while using a mobile app. 1. Typically, online apps consume a lot of data. Even when a minor change is made to the app data sync happens for the entire payload. 2. In locations with network limitations, accessing data from backend service may impact the productivity negatively. Limitation may include lack of data network or network restrictions. To overcome these issues, organizations are implementing offline apps to improve the efficiency of their apps. Offline objects improve app availability, improve performance by negating the impact of network latency, optimize data transfers by syncing only delta changes, maintain a local DB that is consistent with the backend database. Object services allow an app developer to conceptualize their app model in terms of objects. To enable offline objects for an app, you must first define an object service, link it to the backend, map the fields, and enable offline objects for the app. Offline objects comes with a backend that has its own object structure. With the object model, you can set the filter to select the data that you want to share. Please note that you do not need to change the Fabric app configurations if you change the backend, Salesforce, or SAP. However, you should map the objects of the app data model with the objects of the new backend database. In this example, the front end is a field service app. This app comes with front-end logic that interacts with the app data model. The app contains details of objects, such as order, address, tasks, and materials. The client app interacts with these objects. You can map these objects with the back-end objects, one-to-one, one-to-many, and many-to-one relationship. Offline objects provide a sync interface between enterprise databases and the local database on the device. This data sync helps the app to access the object data while offline. Offline objects provide sync capability on the top of a relational object model. You can configure the filters on these models to select the data elements to be synced. If you want to edit or roll back some of the changes you made to the data, you can roll back the data to the previous state. In case of any conflicts between the client and server updates, you can define the conflict resolution policy. The server maintains an upload cache for 24 hours. So, if the app sends the same data again, then the server informs that the data is already synced. Offline objects also support batching and progress tracking. You can also invoke APIs to pause and resume the sync. You can determine synchronization policies such as the only upload or download the data or sync last state only. You can also run sync parallelly across multiple object models. Please note, you can also enable tracking for all CRAD verbs, such as get, post, put, and delete. In the online mode, the data is sent directly from the client app to the backend using SDK calls. The operations, such as create, read, update, and delete, happen directly between the client app and the backend. Whereas in the offline mode, these operations happen between the client app and a local database that is stored on the mobile device. When the device does not have network connectivity, data is stored in the device local database. When the device gets the network, the client app makes a sync API call. The Sync API call sends all the data stored on the device local database to the backend. Within 5 steps, we can configure an offline object service. Step 1. Configure Koni Fabric. Step 2. Setup function. Step 3. Perform sync function. Step 4. Change the online mode to the offline mode. Step 5. Test the app in the Visualizer app viewer. In the Koni Marketplace, you will get the Work Order Management app for both online and offline mode. You can download the Work Order Management offline enabled app from the Koni Marketplace to start working on the sample. The Work Order Management application requires the following user roles. The supervisor uses the desktop web application to assign the tasks. The technician uses the mobile application to update the details about the tasks. Now, consider a scenario where a supervisor creates a work order through the desktop web app. The supervisor assigns the work order to a field agent who is going to service the request in a remote place. Assuming that the place does not have continuous network connectivity, the technician will need an offline app to update the details. Please note, the Work Order Management app is developed using Koni Fabric and Koni Visualizer. After importing the Work Order Management app to the workplace, let us configure an offline object service using Koni Fabric. In the Configure Services tab, go to the section Objects. You will see an object service named WOM Objects. Click WOM Objects to view the definition of the object service. Observe that the endpoint is set to storage. To enable mobile offline synchronization, check the option Offline Enabled. In situations where some changes are made to the data on the server and the app, when they are synced, there can be a conflict. For such scenarios, you can define the conflict resolution policy in this step. Options are Client Wins, Server Wins, and Custom. A custom option is also available to specify a Java class that contains a custom code to resolve the conflict. For this demonstration, let us select the Client Win option. So, in case of a conflict, changes made at the client side are retained. If the Enable Upload Cache checkbox is enabled, the value of upload cache is set to true to avoid the duplicate data on the server. Also, the data uploaded for offline objects are cached for 24 hours. Click Save and Configure to proceed further. Next, navigate to Object Configuration. Here, you can see the object data model and mapping. The role, Tech Work Order, Technician, and Work Order are objects. Each update to an object is distinguished by a primary key and a delta context. In case of Work Order Object, Work Order ID is the primary key, and last update date time is the delta context. Here is the soft delete flag field. Whenever you delete a record, it is marked for soft delete, and its value is set to 1 in this field. Once you are done with the configuration, save the object. Let us publish the app to update the changes made in it. From the Publish tab, select the environment and click Publish. Now, once the app is published, let us modify the app in Koni Visualizer. Next, navigate to Koni Visualizer to modify the client app. Connect the client app with the Work Order Management backend app. Generate the object model. The generated object model receives the metadata of the object from the server. So, the app knows what all the objects are available, their methods, and relationships. Now, the first step in invoking offline objects is to initialize the setup. The setup sync function is included in the pre-show action of the login form. This setup creates a schema at the launch of the app. The offline objects.setup function is called the setup sync function with the methods success and failure. We can also pass parameters in this setup function along with success and failure methods. A sync button is included on the home form. This is to sync data between the backend and the local database. The perform sync function calls the start sync function of the object service. Here, the download and upload batch size parameters are passed. The functions onSync success and onSync failure are included to perform the required action in case of success or failure. An additional method, onSync progress, is added, which can be used to show the sync progress. Next, the access mode has been changed from online to offline for the technician object model. So, the app receives the data from the local database or device database, and it will not make a network call. Finally, build the app. In this scenario, we assume that a client needs the house roof to be repaired. So, the supervisor will create a priority work order for it. This application has two components, a desktop app and a mobile app. Both can run either online or offline. To show a cross-functionality, we will run one app as online and the other as offline. This is an online desktop app. A supervisor will log into the app and create a new work order, such as roof repair. Here, the details are provided. Please note that there is an option to upload binaries, so the images can be added for reference. Next is to assign the work order to a technician. Now, log in to the mobile app. On clicking the Sync button, the latest work orders are downloaded. After synchronization, it shows the list of uploaded and downloaded records. In the notification tray, the latest work orders that are assigned to the technician appear. On clicking the work order, the details can be viewed. When the technician accepts the work order, it shows status in progress. Again, on clicking the Sync button, the status will be sent to the server, and the same will be shown in the Supervisor web app. After finishing the work, the technician uploads a new image and marks the work order as complete. The status changes to completed. Again, on clicking the Sync button, the changes are uploaded to the server. The supervisor must refresh the data to see the updated work orders. In this video, you've learned what an offline object is, its architecture, how an offline object-enabled app syncs the data between the server and an app. This ends the configuration of offline objects. Thank you for watching this video. For more information on offline objects, visit www.basecamp.koni.com. Here, you can find documentation and articles.